There we go. So with properties, there are certain things that we use in algebra, certain sort of truths that are used to our benefit. And there's certain things we want to avoid. First thing we want to avoid are divisions by 0. It doesn't matter what number A happens to be. A could be 0. A could be pi. Again, A is going to be a variable. It's any number. We just don't know which one. Whatever number A represents, you can never divide it by 0. That's considered undefined. So that's one thing to keep an eye out on. The other thing, associative. We haven't gotten into this yet, but we'll get to what are called orders of operations. And order of operations tells us when we should add, subtract, multiply, or divide. So if we have something, say, like this. A question I might ask is, well, what should we do first? Multiply or subtract? And you get different answers depending on which one you choose. If you multiply first, you'll get 6 minus 1, or 5. If you subtract first, you'll get 3 times 1, or 3. So depending on which one of these you choose first, you're going to get a different answer. And that's a problem. You don't want what's called ambiguity in mathematics. Mathematics is very cut and dry. So we'll talk about that later. But something that helps us deal with PIMDAS and sometimes lets us work around it is the associative property. And it says this. Let's say we're adding 3 things. A plus B, and then plus C. Now, order of operations says we do what's in parentheses first. But if we're adding, we can shift the parentheses. Like so. Now, this is sort of surprising. If I put parentheses here, I can move them over here. I'll give you an example. Let's say we have 3 plus 2 plus 1. Well, that's equal 7. I'm sorry, 6. Ooh. That's multiplying by 3 and 2. But let's do this. Let's go 3 plus 2 plus 1. Well, we'll do this first. This is going to be 3. And then 3 plus 3 is also 6. So what it says, it doesn't matter which addition we do first. If we have these additions here, you're going to get the same answer. A chain of additions will give you the same answer. Same with multiplication. So we could do this multiplication first, or we could do this multiplication first. It doesn't matter, we're going to get the same answer. So this will be 15 times 2. So that's going to be 30. But if I do this, 2 times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is also 3. So we're going to get the same answer. So with the parentheses, it means we can change the order as long as we're always multiplying or we're always adding. Where this doesn't work, this is not true for subtraction or division. So subtraction and division are not associated. So 8 minus 4, and then we subtract 2, we'll get 2. But if we do 8 minus 4 minus 2, again, doing it from the parentheses first. 4 minus 2 is 2, then 8 minus 2 would be 6. So subtraction is not associated. Neither is division. Eight divided by 4 is 2, and then 2 divided by 2 is 1. Four divided by 2 is 2. 8 divided by 2 is 4. So in this case, where you put the parentheses does matter. So subtraction and division are not associated. So the next set of properties, commutative. So commutative is the order of things. So for example, A plus B equals B plus A. We can switch the order. So 4 plus 2, well, that's 6, but also 2 plus 4. That's also equal to 6. So the order doesn't matter. Now, this is true for addition. It's also true for multiplication. So A times B equals B times A. So 2 times 4, that's equal to 8. And 4 times 2, that's also equal to 8. The order didn't matter. Now for subtraction and division, this isn't the case. Eight minus 4 is 4. 4 minus 8. Let's review how we do with negative numbers. 4 plus negative 8. And the way we compute this, we take the positive version of everything. That's our first step. Second step, we subtract smallest from biggest with the positive version. That's our preliminary answer. And finally, since the biggest positive came from a negative originally, that means our answer is going to be negative. So that means 4 minus 8 is -4. You got two different answers by switching the order. So that means subtraction is not commutative. Neither is division. 8 divided by 4 is 2, but 4 divided by 8 is 1/2. Two different answers. So addition and multiplication, once again, they come out winning. They're commutative. But once again, division and subtraction aren't. They're not commutative. So what this sets us up for is what's called distribution. Why even mess with these properties? Well, the reason we mess with these properties is when we have something like this. Oh, a little different. Let's go with this. We're going to try to solve for x. Hopefully we get to do some of that today. I think we're at 1-3. We might be able to a little bit. So to solve for x, we're always told that we need to follow the orders of operation. So that means doing what's in the parentheses first. Now, x is a number. Because it's a number, we can subtract from it, we can add, we can multiply or divide. But there's an obvious problem with this. How can we subtract, add, multiply, or divide if we don't know which number x is? We can only successfully pull this off. We can always do it between numbers, but we can actually only pull it off if we know what the numbers are. It's like me walking up to you and saying, could you subtract this number from that number? If I say that exactly to you, subtract this number from that number, what would you say? It's like, well, I know how to subtract, but you got to tell me the numbers. So here's the problem with this. Parentheses say we need to subtract first. We don't know the number yet, but we're trying to find out the number to begin with. How can we get around this problem? There's a trick called distribution that does it for us. So let's take a look at 3 times x minus 1. Well, it's 3 times something. So this is going to be x minus 1 plus x minus 1 plus x minus 1. Now, in fact, let me change this around. This is going to get a little confusing. So let me go back to this. Let's say it's x plus 1. We'll do that. Because when you put in the minus sign, there's a little more going on. So I don't want to confuse things. Let's say we have x plus. Well, if we rewrite this as 3 of these added together, and that's what the definition of multiplication is, well, this doesn't seem to do us any good. It's still in parentheses. We still have to do what's in the parentheses first. But what did we learn about commutativity, associativity, and addition? Well, when you're adding, you can associate different summations. You can add these two, or we could add these two if we wanted to. And with commutativity, the order that we do the addition doesn't matter. So if we can associate, we can do, say, add all the x's together, add all the 1's together, according to associativity. And commutativity also says the order that we do these things doesn't matter. Then we can ignore these parentheses. That's a big deal. We can do this. And this is only because we're working with addition. I'll talk about the version with a minus, but let's do this first. There's a very slick trick to work with the minus on. So now we do it in the parentheses. Well, x plus x plus x. We have 3 x's. So when you add x up 3 times, by the definition of multiplication, that's just 3 times x. We have 1 plus 1 plus 1, well, that's 3. So here's the idea of distribution. Using the freedom that associativity and commutativity give us. We'll skip all this middle stuff and jump from here to here. And so now, these parentheses that were forcing us to do this first, but the x won't let us do it until we know what x is. Now, how are we going to do this if x is something we're trying to find in the first place? Well, we can use distribution to get rid of those parentheses. And that's the power of it. It lets you get rid of those parentheses. And so we come up with a shortcut. So we have 3 times x plus 1. This was 3x plus 3. That's what we found out. So we can say this is 3x plus 1, and we distribute the 3 to the x and to the 1. And we distribute it as multiplication. So we get 3 times x, 3 times 1, or 3x plus 3. And that's how we distribute. Now, what about the situation with a minus sign? Well, it's a little more complicated, and so that's why I didn't want to go with that example to start. Well, let me show you how that would work. A trick that we're going to use a lot in this class is rewrite subtraction as adding a negative. We can do that. And now, since we're adding everything, we can use our rules of distribution. I'm going to derive it from scratch. We're going to get the same thing. Since we're adding, and this is just a number, well, we can get rid of the parentheses using commutativity and associativity. Or we can regroup them as we'd like. And so now what we're going to get three times x and 3 times -1, or 3x plus -3, or we can take adding a negative and work backwards and just call it subtraction. So in the end, we can distribute when there's a minus just as well as we do with a plus. The mathematics behind it can get a little complicated, but in the end, here's the idea of distribution. And we're just going to wrap this up in a shortcut that makes life easier. So whether we're adding or subtracting, we can always distribute. And that's going to help us solve equations. So when we get x minus 1 in parentheses, instead of staring at it and trying to figure out how do we subtract x minus 1 first, when we're solving for x to begin with, we can distribute to get rid of those parentheses, and then we can solve for x as we want to, using the techniques that we're going to learn. So any questions about that? All right. So we're still in properties. The next kind of property is going to be division. Now, in division, we talked about this with addition and subtraction, that we can call subtraction I'm going to start out with that. A minus B is A plus negative B. We can write subtraction as adding a negative. Well, this allows us to use commutativity and associativity. Because remember, subtraction is not commutative or associative. But if we write it as this, A and negative B, we can use addition and multiplication associatively or commutatively. Can we do something with division? Well, A divided by B, and remember fractions are the same as division, we can rewrite this as A times 1 over B. So these aren't commutative. We can't switch the order on these, but we could rewrite them like this and then switch the orders, where we have 1 over B times A, or A times 1 over B. Let me give you an example. So going back to subtraction and addition, 5 minus 3 is 2. We can't do 3 minus 5. That's negative 2. But we could do this. We can do that. If we make this 5 plus negative 3, then we can switch the order of 5 and negative 3, and regardless of which order we use. 5 plus negative 3, that's equal to 2. But negative 3 plus 5, that's also equal to 2. So that's another way to kind of get out of the constraints of, in this case, associativity and commutativity. Now what about division? So 8 over 2 is equal to 4. But if I do 2 divided by 8, we'll get a fourth, not the same as 4. But we can do this. 8 times a half is equal to 4. But because this is multiplication, we can write 1/2 times 8. That's also equal to 4. So if we rewrite division as multiplication with a fraction, then we can switch things around if we want to. We could also use associativity as well. So any questions about that? So order of operation. So order of operations, this is something that helps us answer this question. Which should we do first? Multiply or subtract? There was a meme that went around Facebook, I think last year, that had a question like this. And it was the test if you were a genius or not. So we're going to be geniuses. We're going to figure this out. The technique is called PEMDAS. And it works in this direction. And what it stands for. Parentheses, exponents, multiplication, division, addition, and subtraction. So what it says is this. You're going to do what's in the parentheses first. And then you're going to calculate exponents. Then you'll do any multiplications or divisions. And then you're going to do addition and subtractions. So it works in this order. Now when you get to multiplication and division, these are actually equals. So you don't arbitrarily choose one over the other. What you do is you start on the left side of your calculation and you work your way to the right. And you perform the multiplication and division as you go. Same thing for addition and subtraction. Now, once you've taken care of these, then you can move on to these. So there is an order from here to here. But amongst just addition and subtraction themselves, they're treated as equals. And you calculate them as you encounter them, going from left to right. So we're going to do some examples. I'll pull some from the textbook. So how do we compute this thing? Well, we don't have any, we have a number in parentheses, but there aren't any calculations. So we don't have to worry about parentheses. What this is just saying is we're squaring the negative number. And again, keep in mind, -3 squared negative times negative is positive. But this has a different meaning. This is -1 times 3 squared, or -1 times 9, or -9. Now that can be a bit of a surprise. So keep that in mind when you're doing these problems. This is going to give you that. But with these parentheses, we're doing -3 times -3 gives you 9. We're going to get 2 negatives. But this one, we're just going to get the 3 squared. There's only 1 negative. So that's just a little tricky thing they'll throw at you. So there aren't any calculations in parentheses. So we just got to go through and do exponents. So exponents are gone. There are no calculations in parentheses. So now we move on to multiplication and division. Well, to do multiplication and division, we're going to go from left to right and see if we encounter it. And we actually do. You go through here. Division. So we perform this division first because it's to the left. This is a multiplication in here. We're going to save that for later. So we get 4 minus 49 plus 8 divided by 2 is 4. And we still have a times 9. So now we do this multiplication. So now we're done with multiplication and division. They're all cleaned out. We can move on to addition and subtraction. So again, we go left to right. So starting on the left, you get 4 minus 49. So -45. And then finally, we have this last addition. So this is going to be -9. Questions about that? So let me do another one. All right. Now for this one, this is a big division. That's what this stands for. And what we do for these type of problems is we do the division last. We come up with a number here, and we come up with a number here, and then we divide those two numbers. So looking at the top, well, there are no parentheses or anything. So we could just work them from the top. So this will be our top. 13 minus 3 times -2 to the 4th. Well, in this top expression, we don't have any calculations in parentheses. So we can just go to the exponent here. We'll get 13 minus 3 times, and this is going to be 16. -2 to the 4th power is 16. Now we have to choose between subtraction and a multiplication. We do multiplication first. And then 3 times 16 is 48. Finally, we do the subtraction. 13 minus 48, we'll get -35. So this is what's going to go on top. Now let's take a look at the bottom. Now in this case, we do have a calculation between parentheses, 6 minus 10. So we better do that first. And 6 minus 10 is going to be negative 4. Well, now we can do the subtraction. Now this is where we have those double negatives. Minus sign next to a negative sign. And with the parenthesis in the way, we don't worry about that. We kind of ignore it. So this is going to be our double negative. It becomes a plus. And then 3 plus 4 will become 7. So that's our bottom number. So finally, plus 7. If we take negative 35 and divide by positive 7, we're going to get negative 5. We saved this large division for last. Questions about that? So finally, simplifying. Well, you want to take a couple examples. Let me do another one with this. Let's see here. Let's say we have something like this. Now, this here are absolute values. Now, absolute value makes everything that's negative into a positive. So let's say the absolute value of negative 1 is 1. The absolute value of 1 is also 1. So if it's positive, it stays that way. If it's negative, it becomes positive. Now, with absolute values, we're going to treat these like they're parentheses. We do the calculation in the absolute value first. So we have parentheses here, and technically we have parentheses there. So 3 minus 7 is negative 4. And then the absolute value of negative 4 is positive 4. We're going to compute the absolute value first. So now we've taken care of our parentheses, or calculations between parentheses. So now go to exponents. Negative 1 squared is 1. Now we have to choose between subtraction or multiplication. Multiplication is first. And then finally, we get to subtract 1 minus 8. That's going to be negative 7. Questions about that? All right. There's one more of these I want to do. Have to squeeze this one in there. This is 12 divided by 2 times 3. Now we've got a square root in here. There's different ways of thinking about square roots. You can think of them as fractional powers, and I think we do get to talk about this later in the class. It's kind of a neat subject. It's a really cool subject. The thing with square roots is we're also going to treat them like parentheses. So if we have a square root, we want to compute what's in the square root first. So double negative becomes a positive. Then we want to do the addition. The square root of 4, we want to calculate that. Now, technically what this is actually an exponent, but we can treat it like a parentheses. We can calculate this first, just like we calculated the absolute value first. So square root of 4. So all of our parentheses are gone, or implied parentheses, implied exponents, they're all taken care of. If you want to know what a square root is, by the way, why do I keep referring it to as an exponent? Square root of 4 is 4 to the power of 1/2. But that's something we'll talk about later. For now, we can just treat square roots as parentheses, and we need to compute the square root first, just like we computed the absolute values first before we do anything else. So now we've got a subtraction, an adding, a division, and a multiplication. There are no exponents or parentheses to worry about. Well, multiplication, division come next. We treat them as equals. So we start from the left, we squeak through, and as we encounter them, we do the calculation. So we hit a division first. So we get 15 minus 2 plus 12 divided by 2 is 6. And we still have the times 3. Well, again, we're sweeping through. Now we got this multiplication to do. So 15 minus 2 plus 18. Now we move on to the next pair, addition and subtraction. So again, left to right, we've got 15 minus 2, 13, and finally 13 plus 18 is 31. And that's it for order of operations. Questions about that? So what I want to talk about in section 1.3. So we're now getting into section 1.3. And what we're going to be talking about here is graphing. Now again, this is a bit of a review. It's been a while since you've seen it. I'll try to remind you as best as I can here. When we graph a function, what we want to do, we talk about a function first off, is we talk about inputs and outputs. So we have this thing called f of x equals y. What this means is we take a number x, we put it into some function f, and it's some kind of a process. And you get an output y. So for example, let's say f of x equals x squared. Well, we're going to substitute like we did before. Let x equal 2. So that means everywhere we see an x, we replace it with 2. So this means we get f of 2 is equal to 2 squared. So what's 2 squared? Well, it's 4. So we get 4. So this is how we write this up. We'll sum it like this. Two went into F, and the output was 4. Or to put it another way, f of 2 is equal to 4, where the input is here and the output is right there. Let's do another one of these. Let x equal 3. Well, this means f of x, let's keep x squared. So that means we get f of 3 is equal to 3 squared, which is equal to 9. So that means we input 3 into f, and we output 9. Or put another way, f of 3 is equal to 9. Now, questions about that? All right. So how does this become a graph? Well, what we might do is see what is the output for many different inputs. So we might say this. Let's say we have x, and then f of x equals x squared. So if we plug in, say, -2 for x, we'll get f of -2 is -2 squared, and then -2 times -2 is positive 4. So here's our input, here's our output. We might say -1. We might try it with 0. We could try it with 1. Or 2. So what we have are all the inputs, and for each input, we're getting an output. And sometimes the outputs are the same, but that's all right. So questions about that, this idea of outputs and inputs. So another thing we can do, we can clean this up. This is kind of messy. So we have our inputs, and we have the corresponding outputs. So a lot of times when we generate inputs and outputs, we'll leave out all these middle calculations. We'll do those on a piece of scratch paper. And we'll write things like this. So we'll call the outputs y, the inputs x. So if we input -2, we'll get 4. If we input 1, we'll get 1. Input +2, we'll get +4. And often what we'll do is we'll write these as coordinates, where the x or the input value is first, and the output value is always last. So the input is always first, the output is always last. Now there's a term for this. It's x comma y. Because we always consider the first number an input and we always consider the last number an output, we call this an ordered pair because the order matters. So we call that an ordered pair. So there's your input, there's the output, input, output, input, output, input, output. Questions about that? So what does this have to do with graphing? Well, if you're looking at these, it's numbers. And if you're comfortable with numbers, you can look at these and say, okay, I think I see a pattern here. You kind of do. So -2, -1, 0, 1, 2. But we're just moving along the number line is what we're doing. But take a look at the outputs. 4, 1, 0, 1, 4. It kind of boomerangs a little bit. 4 small to 0 and then grows back up to 4. Well, there's some kind of a pattern here. And what we'd like to do, if we can, is draw a picture of what's going on. And that's where we get into graphing. So this is called the Cartesian plane. And the Cartesian plane, it's contained of basically several parts. You have what's called the x-axis along here. You have the y-axis that's vertical. It's the intersection of really two number lines. A number line like this, and then a vertical one like this. So we have negative to positive, negative to positive. Where these intersect, this is a special coordinate, 0, 0. And we call it the origin. So that's 0, 0, or the origin. Now we break this up into quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So those are the parts of the Cartesian plane. You have a number line this way, negative to positive. You have a number line, negative to positive, going vertically. We call the horizontal number line the x-axis. We call the vertical number line the y-axis. Where they come together, that's the point 0, 0. We call that the origin. And we break this up into quadrants. Quadrant 1, 2, 3, 4. They go around counterclockwise. And we call that the Cartesian plane. So how do we use this to graph? Well, let's say we have this. X comma y, what we might call a coordinate pair, but it's also an ordered pair. Let's call it 2, 1. So that's X and that's Y. X is always first, Y is always second. Cool. On our Cartesian plane, there's our origin. The way we graph a point is this. Here, X is equal to 2. So we draw a vertical line through X's 2. Now here, Y is 1. So we do a horizontal line of Y is equal to 1. And where these lines cross, that's where we locate our point, 2, 1. So the X vertical lines, the Y horizontal lines. Let's do another one. Let's say we have X is 2, Y is -3. Let me change this. We already used X is 2. Say X is 3. Let's go 3 and -3. Now X is 3. So that means along the x-axis, here's X, and here's Y. Along the x-axis, we go to 3, and we place a vertical line. Now Y is -3. So we move along the y-axis, and then at Y is -3, we put a horizontal line. And so we get 3 and -3. So how does this let us graph functions? Well, first off, any questions about that? So how does this let us graph functions? Well, let's take a look at our inputs and outputs from before. I'll put them horizontally. We'll do this graph, and then that'll be it for today. Inputs, outputs. So first off, X is -2 and Y is 4. So you have this vertical line x is -2. Horizontal line, y is 4. So where these two lines meet, we've got a point. So I'm going to erase these though. Now, a pro tip, what you can do is you can, instead of doing these horizontal and vertical lines, you could say, I'll walk out to x is -2, and then up or down to find y is 4. But we'll talk about those a little later. We'll save the pro tips for another time. We'll have -1 and 1. So x is -1. Put a vertical line. Y is 1. Horizontal line. Are they cross? Put a dot. Next up, 0 and 0. X is 0. So vertical line at 0. Y is 0. Horizontal line at y is 0. Put a dot where they cross. Next, we have 1 and 1. So at x is 1, vertical line. At y is 1, horizontal line. And where they cross, put a dot. Finally, we have 2 and 4. So x is 2, vertical line at x is 2. Y is 4. Horizontal line is y is 4. I need to extend this, don't I? These horizontal and vertical lines go on forever. Sometimes I may try to take a shortcut by not having to go on forever if I don't think I have to, but sometimes you do. And where these cross, there's a dot. Now I get rid of those lines. So now what I do is I connect the dots. And one thing about connecting the dots is you connect them as you go from left to right. So you connect them starting with the leftmost dot all the way to the rightmost dot. So you go from here, the next dot over is this one, next dot over to the right is this one, next dot over to the right is this one, next dot over to the right is that one. And so looking at this, we just go boom, 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 but we're always moving to the right. And that's how we graph that function. And sure enough, there is kind of a boomerang pattern. As you go from -2 to 2, we start at 4, drop down to 0, and go back up to 4. And that's how we graph. So I'm going to stop here. We're actually very close to finishing section 1.3. What we're going to talk about next is we'll practice this again. We'll look at some pro tips to make it a little faster. And then we'll look at what are called canonical functions, like y equals x, y equals x squared, y equals x cubed, y equals absolute value of x, y equals square root of x. These are functions that you sort of just memorize, like you memorize vocabulary words, and you just memorize the general shape of them. And then you can make little modifications to them as you go along. But we'll talk about that next time. In the meantime, I'm going to talk to Carolyn again. I'll see if we can figure out the access issue again. And then I'll also talk to my department chair about making those videos accessible. I think I just need to add you as one of my team members and not just hit share, but you have to be invited over into sort of the domain that we're in. And I'll make sure I have all your names and emails listed down to do this. I just need to make sure I'm adding in the right part. I need to do your emails or your names. And once I get that figured out, hopefully that'll solve our video problem. So other than that, that's it. I'll still post the link to this video. Hopefully that means it'll be all that's going to be live tonight. Homeworks are postponed. 1.1, 1.2 are due on Friday. And we'll just adjust the homeworks as necessary so no one falls behind or gets a bad grade because we have these delays. So other than that, if any questions, I saw some questions some students asked. I'll go back over those. I'll answer those. And for 1.1 and 1.2, and keep bombarding me with questions. I actually like your math questions. I kind of do. I like math. Hopefully you'll feel the same way. So other than that, have a wonderful afternoon, and I'll see you on Thursday.